Hi, welcome to Mathematics with Tom. I'm Tom, and today we're going to continue our discussion of linear regression. And we looked at this data set of 1, 1, 2, 2, and 3, 2. We calculated R, and we found here that R is about 0.866. This is a great linear relationship. So what do we want to do? What we're going to do now is we are going to find the equation of the line that best fits, as we say, that best fits this data set. So in order to do that, we're going to need a few things. First off, I'm going to take our table and we're going to shrink it down here a little bit. And I'm going to erase. We need a little bit more space now. So let's erase this, and we will calculate now with this new information. So here we go. What we said is that y prime equals b times x plus a. Now, if you've taken an algebra class, you might be familiar with another form of this, mx plus b. This is a little bit different. We'll see why here shortly. So in order to calculate this, I need to give you two formulas, and they might look daunting, but don't worry, we can work through these. Here's the first one. First one is a equals the sum of the y's times the sum of the x squared minus the sum of the x's times the sum of the xy's. And all of that is divided by n times the sum of the x squared minus the sum of the x's squared. And the other value we're going to have to calculate is b. Well, b is n times the sum of the xy's minus the sum of the x's times the sum of the y's over, and it has the exact same denominator. It has the exact same denominator as a, which that's nice for us. We don't have to do so much work. So n times the sum of the x squared minus the sum of the x's squared. So here we go. Let's calculate these values. Now I've left my table up here because we've got all of this information, so we can calculate this. So when we calculate a, let's write these in. So the sum of the y's we said is 5. The sum of the x's squared is our 14. Minus, so notice that the 5 here is the sum of the y's, and the 14 is the sum of the x's squared. And we go minus the sum of the x's, that's the 6 in this we're just looking at this bottom row, times the sum of the xy's, that's the 11. Over n. N is the number of data, there's 3. The sum of the x's squared is 14 minus the sum of the x's. Well, the sum of the x's is 6, and then we have to square it. So let's clean this up. 5 times 14 is going to be 70 minus 66 over 42 minus 36. That's going to be 4 over 6. This is 2/3. 2/3. Okay, there's A. Now, B. B is, let's calculate B. B says we take n, which is 3, times the xy's, the sum of the xy's, that's 11, minus the sum of the x's, which is 6, times the sum of the y's, which we have is 5. Over, and our denominator is going to be the exact same. Well, we know that the denominator, look, that it's going to be this. 30 times 14 minus 6 squared, but we know that's 42 minus 36, which we know is 6. So now we have 33 minus 30 over 6. This is 3/6, which is 1/2. And there it is. That's our line. Y prime is equal to b is 1/2, times x plus a is 2/3. And then sometimes you might see people just switch the order. They might write y prime equals 2/3 plus 1/2 x. Either of those is absolutely fine. So how do we use this information? Well, let's take a look here. Let's take a look at what we've got. Let's do this. I'm going to use this to show you a little idea. So, trying to think of where we can put it. I think we have room down here. So let's take a look at our ordered pair, and then we're going to find y prime, and then we're going to have what's called our predicted ordered pair. All right, well, here's how this works. Watch, this is pretty interesting. So, for example, one of our ordered pairs was 1, 1. If I want to find, now, so in other words, if I had x is 1, the data gave me a 1 in response. That was my y value. Now, let's find out what if I used my model. What would my new y be? Well, it's not to distinguish it between the original y, we call it y prime. Y prime stands for the predicted y value. So y and y prime are usually different. Sometimes they are equal, but they're usually different. So to find that, so y prime, we put in, this is 1/2. Well, x at this point is 1 plus 2/3. So we have 1/2 plus 2/3, that's really 3/6 plus 4/6, that's 10/6. Oh, goodness gracious. No, that's not right. I gotta write this out. So this is going to be 3/6 plus, I'm gonna have to scoot that over. 3/6 plus 4/6. This is 7/6. So our predicted ordered pair is 1, 7/6. Okay, let's do this again. What about 2, 2? Well, 2, 2, that would be y prime equals 1/2 times 2 plus 2/3. Well, that's going to be 1 plus 2/3. That's going to be 3. This is going to be 5/3. So my predicted ordered pair is going to be 2, 5/3. And let's try one more. And let's try something, let's try one more. 3, 3, 2. The ordered pair is 3, 2, but really all we care about is the y prime. Well, that comes from 1/2 times the 3 plus 2/3. Well, this is going to be 3/2 plus 2/3. This is going to have a common denominator of 6. So that's going to add up to 13/6. You might want to double check. 3, 13/6. Now we're going to do one more, but we're going to do it. I'll do it in this green, and we're going to put it up here. What if I wanted to extend this concept out further? For example, what if I was wondering something out here? For example, when x is 4, what would y be? So this would be a total prediction. We don't even have a data value for that. But if we did find a data value for that, what would our model predict? Well, what we would say is, we'd say, well, y prime is 1/2 times 4 plus 2/3. This is going to be 2 plus 2/3. This is going to be, let's see, 6, 7, 8, 8 thirds. 8 over 3. So that the ordered pair would be 4 comma 8 thirds. So if I was to go and plot that, 8 thirds is the same as 2 and 2 thirds. 2 and 2 thirds, this would be right about, with my line, would be right about there. So let's do this. Let's go and graph these. There's 2 thirds, 2 and 2 thirds. And let's see, at 1, 1, we're at 1 and 7, 6. So 1, so 7, 6 would be right about there. 2 comma 5 thirds, here's 1, here's 2. 5 thirds is really the same as 3, 4, 2 thirds, so it'd be about there. And then 3, 13, 6, oh boy, 13, 6 is just above 2, just a smidge above 2. So this first yellow line that I made was my kind of a guess. But now look, if I just connect these dots in the line, here's my actual line. And you can see those are my predicted values on the orange. And then the green are my original data values. And what we're seeing here is this little space in between them. This would be our error, and we'll see that in a little bit. But you can see that there's not much error in these. What we predicted was quite close to the original data value. And that is how we calculate the line of best fit. I hope that helps. And thanks for watching.